Digital systems prevail over analog systems. Digital systems have some advantages that justify this prevalence. In this video, we will analyze these advantages and we will comment also on some drawbacks of digital systems versus analog systems. The main difference between analog systems and digital systems is the format of the information to be transmitted. In an analog system, the information is encoded in a continuous time waveform, like this one in this picture for a voice signal, for an analog voice signal. In digital systems, the information to be transmitted is encoded in a sequence of symbols, typically binary symbols, ones and zeros, typically bits that are transmitted at a given symbol rate. And as we said before, there is a clear prevalence. Currently, there is a clear prevalence of digital communication systems. These are the main advantages that justify the prevalence of digital communication systems. And the most important one is the first one, the regeneration capability. When a signal is transmitted, analog or digital, there is always a distortion that happens during the transmission. The received signal is in general different from the transmitted one. The design will try to minimize the distortion to obtain the maximum fidelity, but the distortion can never be avoided completely. And in analog systems, if we retransmit signals, the distortions are accumulated during the transmission. We transmit this signal and then maybe we can receive this signal with a distortion. If we retransmit this signal, the distortion is accumulated. If we retransmit this signal, the distortion is accumulated. And in analog systems, this accumulation of the distortion cannot be avoided. In digital systems, the ones and zeros are initially converted in electrical signals. Here we have a very simple example for a binary transmission. The 0 is encoded with a low level and the 1 is encoded as a high level. Each capital T seconds, a bit is transmitted, low level a 0, high level a 1. The simplest possible encoding for binary symbols. As in analog systems, when the electrical signal that is transporting the bits is transmitted, some distortion happens. However, there is a very important difference with respect to analog systems. At the receiver, in any symbol interval, there are only a finite number of possibilities. Here, we can only have a low level, a 0, or a high level representing a 1. It is possible to compare the received signal with the two options. In this case, the received signal is more similar to the lower level and this level can be regenerated. And we can repeat this procedure in any symbol interval. In the next interval, there are two possibilities, high level, low level. The received signal in this interval is more similar to the high level than to the lower one. We can regenerate the signal in this interval. In the third interval, this is more similar to the low level. This is regenerated. In the next three intervals, the signal is more similar to a high level. This signal is regenerated for these three intervals. In the last one, in this example, this signal is more similar to a low level. This low level is regenerated. As a result, considering this digital regeneration capability, it is possible to have at the receiver exactly the same signal that was transmitted. This is never possible in an analog system. If the distortion is higher than the one that we have in this example, that is relatively small, maybe in some intervals the decision about the symbol that was transmitted can be wrong. Errors can happen during transmission. But here we have the second advantage. There are techniques, channel coding techniques, that allow to detect and to correct errors that can happen at the receiver during the identification of the transmitted symbols. Then it is simpler to compensate the distortion that is introduced by the channel. This is called equalization. It's much easier than in analog systems. Another advantage is that the information can be encrypted relatively easily. Just with operations using a binary key, it's possible to encrypt the transmitted information. With respect to multiplex and medium access, it's possible to use alternative methods, code division methods, time division methods, as well as the same mechanism that can be used in analog systems, frequency division multiplex or frequency division multiple access. The information format is independent of the nature of the information. The bits can transport a voice signal, data, video, etc. We are dealing with a system that transmits bits, and these bits can transport any kind of information. And the last advantage is that in general, the circuits are more reliable, cheaper, and more flexible in the sense that many parameters of the modulation are programmable than the circuits that are used in analog systems. Because of these advantages, and especially because of the first one, the digital systems clearly prevail over analog systems. Obviously, digital systems also have some drawbacks, some disadvantages with respect to analog systems. The first one is the need for synchronism, because it is necessary to identify the interval that is associated to the transmission of every symbol. Another disadvantage is that, in general, to transmit an information of the same nature, for instance voice, usually the bandwidth is higher in a digital format than in the original analog format. Although this disadvantage is becoming lower as the compression techniques are improving. And the last potential disadvantage is that many information sources are analog in nature. But this disadvantage is not a serious concern because the analog to digital conversion and the digital to analog conversion are very mature technologies. They are based on the Nyquist sampling theorem, and it's relatively simple and relatively efficient to have an analog to digital conversion or a digital to analog conversion at the receiver.